together an FPGA prototype can be like, well, like having to build your own car instead of buying one with no kit. You have to buy an engine, find a frame that will hold it, bolt on some suspension components. With FPGA prototypes, it's the same. You don't just need FPGA boards. You also need IP and software to help partition your design, modules to plug in, and a way to debug the thing, and the list goes on and on. It's like you have to reinvent your wheels every single time. Hi, I'm Amelia Dalton, host of Chalk Talk. Wouldn't it be great if we could get a nice integrated FPGA prototyping solution so we didn't have to go through all that work every time we need to do a new design? I mean, who needs that? Well, wish no longer. My guest today is Neil Songcuan from Synopsys, and we're going to talk about the shift to fully integrated prototyping solutions. Finally. Phew. Before we get started, don't forget to click that link. There you can find out more information about integrated prototyping solutions from Synopsys. Hi, Neil. Thank you so much for joining me today.
Hi, Amelia. Glad to be here.
Okay, so today we're going to be talking about integrated physical prototyping solutions. But before we get into that integrated physical part, let's talk about why prototyping is important in the first place.
Physical prototyping is important because of two reasons. One is the time to market requirements. And this is where engineers or users want to have early software development, where now they have a pre-silicon platform to do software development as well as parallel hardware and software development. Secondly, to increase product quality. And what we mean by product quality is the capability to find that hard to find software or hardware bug. And also the capability to integrate software and hardware together so that the real world interfaces are validated at the system validation level.
Okay, so a lot of people use homegrown solutions or ad hoc solutions with components from a lot of different vendors. And I've heard people having a lot of challenges with those solutions. So what are some of the issues you've seen with people using these kind of solutions?
Yeah, great question. The issues that we find, or what our customers are telling us on a day-to-day basis, that the solutions that they try to integrate together often has a very high effort in terms of integrating the solutions together or try to customize it to their specific project. And what that does is it puts a jeopardy or it puts a schedule risk into their project. And at the end, what happens is that they would tell us that, yes, they're able to maybe put it together, but now the features are limited. They don't have the full capabilities of a prototyping environment. And the bigger things that they tell us is that the reliability of the solution that they just tried to create. Now, again, rather than focusing on their project or the design, they would then have to maintain their solution that they just created, or they would have to maintain the hardware. Things that are not part of their normal day-to-day projects or day-to-day activities or duties associated with bringing the design for their software development or their hardware development teams.
Okay, let's lay out a roadmap for our discussion here. What do we want to gain from an integrated prototyping solution? And what are the big pain points and challenges that a prototyper is looking to fix with this solution?
So we could break it down by what an integrated prototyping solution delivers. And we, of course, talk to our customers on a daily basis. And the things that they tell us that they most want in an integrated solution is the fastest time to productivity. This is the capability where they're able to have their RTL implemented into the hardware as soon as possible. And once it's implemented in hardware, they want to have the capabilities to do debug on their design, which then would enable them to run more tests as part of their project development process. And while running these tests, be able to run tests on, let's say, smaller IP designs all the way up to large SoC designs. with these large SoC designs, when they do then encounter additional issues when they're going through a software development process or software development project, they want to have a way to shorten the design iteration, where now they're looking at iterations less than 24 hours, where they can have 2 to 3 turns per day in order to continue with their software development flow.
Okay, Neil, let's tackle these issues one at a time and get down to some details. What about bring-up time?
Well, the bring-up time is how quickly, again, a user would be able to implement their RTL onto a prototype. And a lot of these users want to have a bring-up time in less than 2 weeks. They want to get their design and quickly start implementing and see the clocks and the resets and the IOs operating. So we've implemented our protocompiler software where it has built-in knowledge of the hardware, our HAPS hardware, so that it understands, okay, well, how large is the design? How many interconnections do I need to go from FPGA to FPGA? Can I automate this process? So all of these things are known to the protocompiler software so that it efficiently partitions a design onto a HAPS system to do the complete either IP or entire SoC design.
All right, so once our prototype is up and running, what's the next logical step here? I'm assuming it's debug. Is that right? And how do we start debugging with this thing?
Yes, that is correct. Debug would be the next logical thing. Once a user has their design implemented in hardware and things are starting to run, but they want to ensure that it's running properly before they hand it off to their software development team. What we've implemented, again, with an integrated solution is where users have the capability to debug the design and have thousands of signals available in a prototyping environment. With HAPS, we built in debug memory, where basically now the trace debug memory is stored in DDR memory, where users can access that memory and be able to replay the debug event on a standard waveform viewer to debug the design. This is something where we are continuing to enhance and improve because our customers always tell us, I want to use a prototype to debug. I don't want to go back to a software simulator because I may not get to the actual debug. I want to maintain the debug environment in a prototype because I am performing very fast and be able to isolate a design very quickly in a prototyping environment.
Okay, so if I didn't care about performance, I would just do this all in a simulator, right? What kind of performance would we see here?
Yeah, so with a prototype, performance is going to be in, the 100 megahertz range, especially if you are talking about for single FPGAs, multiple FPGAs, and really with a prototype, it's as close to the ASIC speed as possible. Really, that's kind of why users are often using prototypes, because it gets to the ASIC characteristics as close as possible. Now, the challenges associated with IP to SoC designs is that now the design not just is maintained in a single FPGA, it's maintained now in multiple FPGAs. We see these SoCs getting larger, we see a lot of processors, we see a lot of GPUs that are implemented in these particular designs, and a lot of times they'll get not just 2 FPGAs, 4 FPGAs, as even 30 or 40 FPGAs. How do you then be able to maintain the performance on that? Well, what we've done with our integrated solution is that our protocompiler software understands, again, the hardware. It understands the delays from FPGA to connector. It understands the delays from HAPS to another HAPS system. And all of that is done through our proprietary high-speed time domain multiplexing scheme, where it's an automated process with protocompiler. If, again, remember we had our discussion earlier where we talked about how customers are doing these things manually or trying to integrate these together. Well, all of this implementation with protocompiler and HAPS is automated. So it's one less thing that a user would need to do in order to bring up the design and at the same time have the capability to have the prototype running at a very high performance, especially when using multiple FPGAs targeting their specific design.
Okay, so talking about this multiple FPGA scenario, and this has certainly been a challenge of mine in the past. Our designs are getting huge. Internal IP from third parties, processors, GPUs. a lot of stuff. How do we cram all of that into our prototype?
Yes, it's not a very easy thing to do, obviously, because of the complexity that you mentioned. But this is where the fun really begins with prototyping, especially when you have these many components into a prototyping system. The HAPS system, as you mentioned, it supports IP blocks all the way to SoC blocks. And today, with the HAPS systems, we're able to support upwards in the hundreds of millions, 200 millions, or even higher of ASIC designs. And again, these are the designs that incorporate multiple processors, it incorporates GPUs, all of the things that are implemented in a complex and basically now we're seeing it as a normal SoC in these types of ASIC designs. What we see with this is that now customers are looking to increase the flexibility of prototyping systems where they can implement not just a single IP, where also they could implement multiple designs in a enterprise type of solution.
So most teams today are scattered all over the country, heck, even all around the world. So how do we all have the chance to use the prototyping system?
Yeah, that's another great question. And this is where prototyping has evolved over the years, where it used to be just a standalone type of tool or platform for a hardware or a software developer. But now design teams are scattered around the world. So how do we solve this particular challenge with respect to customers' demand? The way we do this is through a global, accessible, or enterprise configuration where HAPS systems can be placed into the company's network. And then now remote sites can access a prototyping system. And a lot of times a customer will have, let's say, a single FPGA system, 2 FPGA systems, or even 4 FPGA systems. How are they able to use these systems with multiple IPs as an example, or even try to implement an SoC into a larger prototyping system? And what we do is our remote capabilities or our remote management system done with the protocompiler software has a way where users then can globally see what resources are available on the enterprise or available on the network server. And what we mean by this, or what a user can access, is now they can access one design, or they can access a single FPGA on a 4 FPGA system as an example. Another way users are using this enterprise or global solution is they could put the same design on 4 different FPGAs and have 4 different users access a single HAPS platform. And this is something unheard of a few years back. Now what happens is that customers are maximizing an FPGA prototype 24/7. The next day, the setup could be, oh, I want to access just 2 FPGAs. Well, now you have the capabilities to put 2 designs on a 4 FPGA system. So you can kind of see where there's so many configurations, so many possibilities where now you could place HAPS systems on a network where multiple users or multiple designers have access to designs where it's only a small design or an IP, or a much larger design on a server system.
All right, so we have our prototype up, we're using it, and bam, we found a problem. But we want to fix this problem, right? And reconfigure the prototype with the fix. With some systems, that can take quite a long time.
Right, you're exactly right. And as we mentioned, we talked about large designs, again, in the hundreds of millions. Customers are expecting the same amount of time from the previous generation. They don't want to spend days or weeks waiting for a compile or a prototype to be completed before they give it back to the software development team. So what we've done and continue to done with our integrated solution and with our protocompiler software is have technology where we're automating the partitioning process or the iterations. We have technology that will distribute the compile runs into multiple processes to, again, shorten the time to where we see many designs now where the turns can be done in less than a day or 8 hours as one example. So what happens is that now you can see designers can have 2 to 3 turns per day where they could just wait maybe a half a day where maybe not necessarily they have access to it, but now a remote site could have access to it as quickly as, again, when we talked about a global access. So these systems could be used essentially 24/7 because of how we could reduce, again, the turnaround time. And now these systems are also on remote sites. So then, again, return on investment on how systems are used, or how HAPS systems are used as a way to do prototyping.
Now, prototyping is really only one part of our overall verification process. How does HAPS fit into Synopsys' system validation and software development ecosystem?
Right. So HAPS, of course, has traditionally been used to do software development. It could be used as a kind of a standalone type of implementation where you are stimulating the design using real-world I/O interfaces. What we've done is look at, well, customers are using designware as part of their SoC. So our entire designware R&D team has a HAPS systems in their lab, and they are validating a particular designware IP as part of their hardware bring-up or RTL bring-up of that designware. What we've done is now reduce the risk or the concern that a user would have is that we validate that designware already on HAPS. It's one less thing to worry about, where now a user can just worry more about the integration of the overall design. Secondly, we have hybrid prototyping. And this is where HAPS now integrates with our virtualizer or virtual prototyping tool, where now you have the capability to integrate with or interface with an ARM type of model that resides in a software host workstation, talking with or interfacing with a HAPS physical prototyping implementation where you could see the USB interfaces, Ethernet interfaces, PCI interfaces, those different type of protocols implemented in hardware where real data is flowing to and from the HAPS system. And then now you have this hybrid prototyping solution where you have the capability to interface with a model that may not have a RTL available, but you have a model available, and thus you can have an early software development platform to do hybrid prototyping. And then lastly, another integration piece that HAPS has with the other Synopsys tools is what we call this verification continuum, where you have a unified compile from VCS to ZeBu with our emulator and HAPS. So now as a common look and feel, a customer would have this kind of a unified compile, and then from there targeting different platforms based on where this maturity of that RTL. And what this whole integration involves from designware IP, hybrid prototyping, and verification continuum is this end-to-end prototyping solution we have where we present more of a complete picture of how users can go from software development to the hardware and software integration, and then finally to system validation with the HAPS prototyping solution.
Okay, Neil, that was quite a bit of information to take in at once. Can you recap the main points for me?
Sure. So one of the items I really want to stress out again is our integrated solution with HAPS and protocompiler. And this is a integrated solution that will enable our customers to have a prototyping solution to have the highest performance, have the capabilities to reduce the implementation time to a matter of a few weeks, and also have the capabilities to do debug on a prototyping system where you have access to thousands of signals. Also have the performance of 100 megahertz to do single FPGA, multiple FPGA, and as well as maintain the performance, especially when you're doing multiple FPGAs to do time domain multiplexing. The solution will support everything from an IP and scales all the way to large SoC designs, and then again have the fastest and most incremental tool flow so that you can do very fast iterations to have your software development team and hardware development team have access to a hardware prototype 24/7.
Well, I think that's all I have time for today. Thank you so much for joining me, Neil.
You're welcome. Thank you very much.
And before we go, did you forget to click that link? Because there you can find out more information about fully integrated prototyping solutions from Synopsys. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to EE Journal's YouTube channel or the on-demand section of eejournal.com.